Have you ever been on the Top Thrill Dragster at Cedar Point? It's pretty exciting. I'm about to go. But take a quick look. Doesn't it kind of look like a parabola? Today's lesson, we will be graphing quadratics, and the graph will always look like a parabola, kind of like the Top Thrill Dragster. Here we have some examples of different forms of quadratic equations. The first one we call the parent function. It just means it's the most basic form of a quadratic, y equals x squared. But we have other forms. You can have a number in front, but it would still be a monomial, y equals 2x squared. You could add or subtract a number at the end, and then you have a binomial, or you can even have a trinomial. And all of them, no matter what form they are, when you graph them, they will be a parabola. Some will open up, some will open down, some wrap around the y-axis. Those three actually is what we'll be graphing today. They all wrap around the y-axis, and then later this one, when you cut it in half, it wraps around a completely different line, not the y-axis. So all different variations of parabolas that you can graph. Here are some key vocabulary that you will need to know. First, standard form is when the quadratic equation is in y equals ax squared plus bx plus c. Leading coefficient refers to a, the number that is out in front of your trinomial. And that number will tell you if your parabola is going to open up or if it's going to open down. And as you can probably already guess, if it's negative, it's going to open down. If it's positive, it's going to open up. Next, axis of symmetry is this vertical line that cuts your parabola in half. And then the vertex is that middle point. So we're always talking about a point, which means it has an x and a y value, a coordinate point. And then it will either be a minimum or a maximum. And in this case, since the parabola opens up, you have a minimum point. But if the parabola were to open down, you would have a maximum point. Now we are ready to go through the steps to actually graph one of our quadratic equations. We're going to start out with graphing one in this form when it is a monomial. And there's something that happens for every single time that you're graphing a quadratic that has a monomial. The axis of symmetry and the vertex will always be the same when you have a monomial. First, look at the leading coefficient. A equals negative 0.5. Because that's negative, make yourself a mental note. I know that my parabola is going to open down. Axis of symmetry, the line that cuts the parabola in half. Because I have that monomial, it is always going to be x equals 0. And if you think way back, how do you graph x equals 0? Well, that is just the vertical line where x is 0, which is the same thing as the y-axis. So the y-axis will cut this parabola perfectly in half. And now for the vertex, for every parabola that is a monomial, your vertex will be 0, 0. So our middle point is going to be right at the origin, 0, 0. And in this case, because a parabola opens down, we're going to have a maximum point for our vertex. So, key parts, now we have to actually get points of a parabola, and we can do that by making an xy table. The cool thing about parabolas, you only have to graph half of it, and then because it's symmetric, you can just reflect half of your points to the other side to graph. So your xy table, you only need a few points. So in my xy table, when you plug in 0 for x, you will get 0. When you plug in 1 squared times negative 0.5 is negative 0.5. When you plug in 2 squared is 4. 4 times negative 0.5 is negative 2. And then plug in 3 squared is 9. 9 times negative 0.5 is negative 4.5. Graph those points. 0, 0 we have, over 1 down 0.5. And we can reflect that point to the other side. Over 2 down 2. Reflect that point to the other side. Over 3 down 4.5. And reflect that point to the other side. And now we can graph our parabola. Man, it must feel so good now that you know how to graph a parabola. So good you maybe just want to stand up and dance. Oh, but wait, you have more to learn. We still have to learn how to graph one more form of quadratics. So far, you learned how to graph when it's a monomial. Now we're going to learn when it is a binomial and we add a number to the end. We're not going to worry about that middle term, that bx, until the next lesson. So we're not going to worry about this full standard form. We're just going to graph this equation, y equals 2x squared plus 3. In this case, the leading coefficient, a equals 2, and because that's a positive number, make a mental note that my parabola is going to open up. My axis of symmetry, the line that cuts my parabola in half, is once again x equals 0, and that will always be the case when you have the binomial. It's the next lesson, once we have trinomials with that middle term, the axis of symmetry is going to change. But for now, we still get to work with quadratics that wrap perfectly around the y-axis. Now the vertex on the last one was right at the origin, 0, 0. In this case, when you add a number to the end, that will change your vertex. Your vertex when you have a binomial is always 0 and then whatever the value of c is. So in this case, c is 3. So our vertex is going to be at 0, 3. 0, 1, 2, 3. So there's my middle point, my vertex of my parabola. And in this case, since my parabola opens up, I know that that is going to be the minimum point of my graph. Now once again, we just have to find the xy table, and you only have to find half of the points, and then you can reflect to the other side. So in your xy table, when you plug in 0, 0 squared times 2 is 0, plus 3 is 3. Well, we already have that point, 0, 3. Now if you plug in 1, 1 squared times 2 is 2, and 2 plus 3 is 5. So over 1, up 5, and then reflect our point. And then when you plug in 2, 2 squared is 4, 4 times 2 is 8, and then 8 plus 3 is 11, which is going to be off our graph, so we don't have to worry about that point. So we were able to very quickly graph our parabola for y equals 2x squared plus 3. So for a quick review, when we have quadratics in either the form y equals ax squared or y equals ax squared plus c, they both will wrap around the y-axis because their axis of symmetry is x equals 0. However, their vertexes will be a little bit different. The monomial is always at the origin 0, 0, while the other one, y equals ax squared plus c, the vertex will be at 0, c. And then it will all change next lesson when we have a trinomial. Good luck with the lesson!